I have both of them here. I have the one that you were asked to look at for the assignment, and then I also have a simplified version, and I want to show you both of them. I'm going to start off with the simpler one because I think it's just easier to visualize. So when you're reading with phylogeny, this little tail here, that's ugly. I didn't do that. This is kind of like your start. It is like your first species begins like right here. When we're reading it, time is always going in the direction of the branching. So on the one that we had to look at for the assignment, it's arranged a little differently. Our first species is, sorry about that, is right here. This is like way in the past. And time is actually going, we would read time going upwards like so. And this would be like the present. And that includes all of the species here. We're basically saying these are all extant. And by that I mean they're the species that exist today, or at least wherever in time the phylogeny stops. Okay? So let's look back at this one now, because this one's easier to visualize, like I said. We want to look first at what a node is. A node is any place on our phylogenetic tree where there is some splitting of some kind. There's a fork in the road. So our first one is, man, I gotta get better about that. Right here. Here's our first node, second, third, and fourth node. And each of these nodes represent a speciation event. And essentially, this is like the last known point in time, because we are looking at this as a function of time, where their most recent ancestor existed, where they all existed as one population, and that population was the ancestral one. So this node is your ancestor. More importantly, it's the most common one. It's your common ancestor between the two forks. So when we're looking back at the one that we had to look at here, we have, some of them are labeled like D. These are all of our nodes that I am kind of coloring in here. And at each one of these, there's a speciation event. And this is also a common ancestor. Well, how do we know that? Like, how do we know that that is where our common ancestor is like the least, that this is like the last known point in time? It's because this is a timeline. So each of these little lines here that are moving this way, it's basically saying, oh, this species, it existed, it existed, it existed, it existed, it existed. Oh, this one still exists today. Whereas over here, it's saying it existed, it existed, it existed. Oh, now there's two new things arising from that. Okay? And something that I don't have pictured on my simplified phylogeny are these here. So this is basically saying that this is a point in time where a new trait has kind of come about, right? So when we're reading the phylogeny, let's switch colors. We have our beginning species, and they split off. They make the painted tunicate turtle, right? I assume it's a turtle. It says painted. Might not be. I don't know. And if we're going this way, it might not be. This here, the cranium, this is something that arose that the painted tunicate, which I assume is not a turtle actually, does not have. It does not have a cranium. But every single lineage coming off of this point would have a cranium. Now let's look at 4 limbs. Anything after this point where 4 limbs arose is going to have 4 limbs, or it's going to at least have had limbs somewhere in its evolutionary line. It doesn't necessarily need to have it now, because we know that sometimes things disappear in nature. So for instance, whales have pelvises because at one point they did have limbs, but now we know that they have fins and they are bound to the water. They would still fall into the category of 4 limbs if they were somewhere on this. I'm not saying that any of these are related, but like if we wanted to put whales here, let's just put whales. Even though they don't have 4 limbs now, they came about after 4 limbs became a thing, essentially. Okay? So that's what all of these things are. So how do we determine relatedness in a phylogeny? So if we're looking at a phylogeny, we have all these nodes, and we know where the common ancestors are. Okay. So now that we know that they have a common ancestor, that means that anything with a common ancestor is going to be related. So every single species, A through E, are related to some degree, but they are not related to the same degree. So if we look at E and D, they have a common ancestor that's very recent. Recent because here is the most recent point in time, right? Now, E and C are also related, right? Because they share a common ancestor at this node, but this is not as recent. We'll just write that on our timeline. Okay, so now that we know that that is not as recent, we can say that E and D are more closely related than E and C. They are related, but they are much less related. So what about this concept of an outgroup? Because that's kind of a weird phrase if you've never heard it before. So let's look at what an outgroup is. So let's go all the way back in time to our first species, to our first speciation event. So we have this node here. Our first node is always going to have an outgroup. An outgroup is essentially the first species to arise from a speciation event that stays the way that it was. So if we're looking here, if we go up and then we go to the right, there's another node, right? So there's not going to be an outgroup there. Whoops. If we go down and then we go to the right, we can keep going and going, and there is no other speciation event. So in this example, A is our outgroup because it arose from the first speciation event and hasn't experienced any other evolutionary things since that point. Okay, so let's look back at this one, and let's identify our outgroup on this phylogeny. So we're going to start at our first node, first point in time. If we go to the right, we go this way. Oh, we ran into a node. Darn. We can't have an outgroup over here, because that's another speciation event, where all these guys are going to share the same common ancestor. We go this way. There's no other speciation event. So this is, in fact, our outgroup. The painted tunicate is our outgroup. And the reason why we're concerned with an outgroup is because the outgroup will always share only one common ancestor. Only one common ancestor with all of the other species that we are concerned with. And that would be this one right here. So if we wanted to compare relatedness again, like we were doing before, and we were able to determine that E and D were more closely related than E and C, we can also say that in respect to the outgroup, right, that E, D, C, and B are all equally related to the outgroup. But they differ in relatedness amongst themselves. So I'm hoping that this explanation of how to read a phylogeny and determine relatedness, how to determine common ancestors, what an outgroup is, I'm hoping that this maybe makes it a little easier to look at. If you need further explanation, you can feel free to reach out. There's also great resources, I'm sure, on YouTube that you can find. I know that this phylogeny that we were looking at is a lot to look at, especially with the traits that are arising being shown. But just remember, it's like a timeline that shows us when speciation events occur, and we can determine how closely related they are based on what sorts of relationships they share at their different nodes. Okay.